All right, nice. So back to the second part. Right. So now we have this question, Right. So before we even go across to the board, right, let's just analyze this. Right. We clearly see that it is in its cos and sine form. No cos square, no sine square. That's cos's and sines. That is in itself the trigonometric form. So we know this is already expressed in the trigonometric form. So you don't need to do anything to it. Right? Obviously, we know it is not in the exponential form because again, the exponential form is in terms of e. Right now we have cos's. So that is clear as day. Third thing, we clearly see that the 2 pi is already factorized in this one, but in this one it is not. So when you're actually ready to do the question, we need to factorize the 2 pi from this. Right? So this here, yeah, let's end up with 2 pi 3f naught t, and yeah, we have pi on 3. Yeah, so that's something to remember. All right, so nice. So we have this question. So let's go and tackle it. So we did this question last video. Make sure you know the three forms. We learned this. Make sure you know this equation. All right, and we learned out the different types of spectrums. The double-sided comes from the complex, single-sided comes from the harmonic, and we did some spectrums, right? Nice. So let's do this one. A little more challenging, but the same concepts. So it's cos 2 pi f naught t and plus pi and 4. All right, and plus cos. So right, it's in the form that we just did. So it'll be 2 pi 3f naught t, right, and minus pi and 3. Right, so nice. So you know it's already in the trigonometric form. So that's done. So the only thing we had to do is expressing it in the exponential form, right? So as we learned last video, we know cos theta, where theta is whatever inside the bracket or the angle, the bracket part with the cos to make it simple, everything, right, is equal to e to the j theta plus e to the minus j theta all on 2. Right, so we just need to rinse and repeat this for this piece here and this piece here. All right, so let's get on to it. So the first piece will end up being e to the j 2 pi f naught t plus pi on 4, and then it'll be plus e to the minus j 2 pi f naught t plus pi on 4. I'll just go and write the half one time because we know it's gonna be in the half, right? So that's the first thing done. That's this here. So now we need to put this piece here. So that'll be plus, you already half one time, e to the minus j 2 pi f naught t plus pi and 4. This is the tree. Apologies. Yeah. All right, 2 pi 3 f naught t minus pi and 3. And then, oops, what am I doing? This is supposed to be the plus. All right. So we do it, rinsing this onto this here. All right, and then it'll be plus a half, then e to the minus j 2 pi 3f naught t minus pi and 3. Yeah, follow still, right? So repeating this equation onto this. So in this first part, this entire thing, 2 pi f naught t plus pi and 4 is theta. So it will be e to the j theta plus a half e to the minus j and theta again. The theta doesn't change. Then we need to repeat this onto this here, where 2 pi 3f naught t minus pi and 3 is theta. So half e, the first piece must be positive, right? And then you slap the theta inside and then plus a half e to the minus 3 and the same amount. So that was the part that made a little mistake, but hope it clarified. So we have this here now. The second thing you need to do is you need to use the power rule. You need to split the two. So if you didn't know a to n multiplied by a to the m, when you're multiplying, you add the power. So it'll be a to the n plus m. So what we need to do, we're going back to this form here. Right, so we're just splitting it up individually. Right, so for the first piece, you'll end up with a half e to the j pi on 4 by e to the j 2 pi f naught t. Right, so that's the first piece. Then you go again plus a half e to the minus j 2 pi f naught t and e to the j pi on 4. Right, so that was this piece and this piece. So you continue plus a half e to the j 2 pi 3 f naught t and then e to the j, you say minus pi and 3, right? Because the angle itself was minus, and then we have plus a half e to the minus j 2 pi 3 f naught t, and then e to the, in this case, it will be positive, but this minus here, and this minus here will give you a plus. Yeah, so that is 1, 2, 3, and 4. All right, so right now it's finally in the exponential, complex exponential form. All right, so we just rinse and repeat. So what we did, we used this onto each of the causes and then expand it. And now we just use this rule to split it up. The reason why we split it is so you can clearly see the phase and the magnitude part easier. So the part with the angle alone, that is where we'll get the phase. All right, and this piece here will give you the magnitude and the harmonic. Obviously, you get the harmonic from these pieces here. Yeah, just make it easier. And also, you clearly see that you'll end up with a double-sided spectrum, as you see. So let's plot the single-sided. I start with the magnitude. Right, so as I said, you get this single-sided from the harmonic form. Right, Rash harmonic form is what we have here. I know we didn't do a question on the harmonic form, but this is the harmonic form. Why? Because if we go back before, the harmonic form is A naught on 2, which is a DC component, which is at the frequency as 0, plus the sum of CK cos, what this part here, 2 pi kf naught t plus theta k. Yeah? So, in a simple term, the harmonic form, anytime you have something with in cos's alone, that's cos plus, that is the harmonic form. Right? So, this first question here was already in the harmonic form, so we could have get the single-sided from it. And the question that we're doing now is already in the harmonic form. They just give us two harmonics, right? So we don't need to do any manipulations of it. So hence we could use it to get the single-sided spectrum easily, right? So in this case, it's single, so there's only one band. So we know the magnitudes here and the frequency here. So we need the harmonics, right? So we need to go back up here. So the harmonics is 1F and 3F. That was the importance of factorizing it 2 pi. So you have 1F notes and 3F notes. So now we got to get the magnitudes of them. So the magnitudes of both of them, 1. But before the cos, yeah. If it was 2 cos, so that'd be 2. Right? So in this case, both of them are 1. So this going up to 1. And this also go up to 1. Yeah? For the magnitude spectrum. So that's it. And then the phase, so the single sided, same general idea, frequency, same two harmonics. So you have your F notes and your three F notes and your phase, we call it theta, I guess. Right? So for one F note, the phase was pi on 4. So go up to pi on 4. And then for the 3F note is minus pi on 3. So that will go down to minus pi on 3. Yeah? Right, so the double-sided spectrum now is a different color. So for the magnitude, so we have double-sided spectrum. So because we know double-sided, we have a negative and a positive, so we had to leave some space. Alright, so double-sided comes from the exponential, right? So from the complex exponential, we see we have a 1 F naught, then we have a minus F naught, then we have 3 F naught, and a minus 3 F, which makes sense, right? So you have your 1 F naught, and your 3 F naught, and then obviously it mirrors. So minus 1 F naught and minus 3 F naught, right? So now we need to get the magnitudes. So as you can see, all of them are a half. So this will go up to a half. This will go up to a half, a half, and a half, right? So, and obviously to label, don't forget to label the axes, magnitude, and this is frequency. Yeah, and then the phase, so double-sided spectrum. So we know it's same axis, there's the same harmonics. So we have 1 F naught, 3 F naught, minus 1 F naught, minus 3 F naught. Let's label my axes one time, frequency, phase. Right. So at 1 F naught, we need to go back to the complex form. So at 1 F naught, this is the 1 F naught term. And the reason why we split it is pi and 4, right? Clearly could see that from that piece thing, right? So pi and 4, and then at 3 F naught is minus pi and 3, right? This piece here. So it'll be minus pi and 3, right? And then put minus 1 F naught, right? That'll be this piece here is pi and 4. Now that's supposed to be a minus because this minus will expand out. Yeah, so a mistake because minus, minus, and this bar plus will give you a minus. And I'll show you why. So now this going down to minus pi and 4. All right, so and then for the minus 3 F naught, you have minus pi and 3. Yeah, so something cool to remember. So that's the end of the question, all right? Something cool to remember. If you have the single-sided spectrum and you want to get the double-sided, watch the trick. So for the single-sided and you want to go to the double, it's just going to be half of what it was, and you just mirror it onto the other side. Same harmonics. So if you want to go from the single-sided to the double-sided with the magnitudes, you half all the magnitudes and you mirror it on the y-axis. So basically like fooling it. So you notice it went from ones to a half, and then it mirror on the other side, right? That is the trick, right? So you half it and you flip it, right? You mirror it on the y-axis, right? This is the y-axis here. That's mirrored in addition to halving it. For the phases, however, it is still mirrored, but it flips. It literally just inverts. Whatever was positive, it will just end up being negative. So the pi and 4, when it go across to minus 1 F naught, it will go to minus pi and 4. And then for this one here, add the minus 3 F naught, this will go back to being the positive. Right, so that was supposed to be a positive. Yeah, so that is a trick. But let's remember, right? So for the magnitudes, half, flip. Alright, so for the phase, it literally just inverting and emergent, as you can clearly see. Yeah, so that's a little trick to do it. So as I said, the double-sided will come from the complex exponential form, and the single-sided comes from the harmonic form, which all the forms were in already. Right, so That's the end of that piece. We'll catch up in the next one.